Well, today what we're going to do is we're going to talk about how to evaluate a limit algebraically. Okay, so I've got a flow chart here that helps us out. And so the first thing we want to do is we want to substitute the value into the expression. So if we look down here at example 1, if I substitute 1 into this expression, I would get 1 plus 3 minus 4, which is 0. So the limit has a value of 0. Well, that works great. If I go right down here and plug it in, how sweet that is. However, that doesn't always happen. So let's try another example. Let's try this example number 2. Now, if I were to substitute -2, oh wow, I'm noticing in the denominator I'm going to have an issue. So if I show my work down here, -2 squared minus 2 times -2 minus 8 all over -2 squared, 2 squared minus 4, I know that the answer is going to come out to actually 0 over 0. Well, this is called the indeterminate form. So if you look up here at this chart, we can see when I substituted the value in, I got the indeterminate form, which just means I can't determine yet what the answer is. So if that occurs, then I'm going to follow the flow chart and I'm going to try one of these three things. I'm going to try to factor, I'm going to try to multiply by the conjugate, or I'm going to try some trig. So in this problem, I do notice that the expression can factor. So if I kind of make some space here for some room, if I were you, I'd go ahead and leave my work, not erase it. So now if I rewrite the problem, limit as x approaches -2, notice I have to write that limit part again because I have not found the answer yet. So x minus 4 over x minus 2, x plus 2, all over x plus 2, x minus 2. So I notice the factors x plus 2 reduce out, and now I can substitute in the number -2. And if I do that, -2 minus 4 is -6, and -2 minus 2 is -4. So the answer is 3/2. Fantastic. Let's look at another example. Number 2. As x approaches 4 of this problem. Well, if I substitute in the value 4, I get the square root of 4 minus 2 all over 4 minus 4, which is 0 over 0. That is not a number, it's the indeterminate form. So it means I need to do a little bit more work. Well, looking at the original problem, this cannot be factored. Ooh, but it's got a radical. So I can multiply it by its conjugate. Now, if you don't remember what a conjugate is, it's basically a binomial. Instead of multiplying it by square root of x minus 2, you multiply it by square root of x plus 2. And what this will do is it will hopefully mix up the expression enough so I can find the value. So I rewrite limit of x approaches 4 because I have not found the answer, and I distribute this, and I'm going to get x minus 4 in the numerator all over in the denominator x minus 4 times the square root of x plus 2. Oh, this is looking good. The x minus 4's reduce out. So then what happens is I have the limit as x approaches 4, and I have 1 over the square root of x plus 2. Now if I substitute in 4, I'm going to get 1 over 2 plus 2, which is 1/4. Woohoo! That was our conjugate example. And last of all, let's look at this example. We have cosine of x over cotangent of x. Well, cosine of pi half, we know is going to be 0. Cotangent is cosine of pi half over sine of pi half. Cosine of pi half is 0, but in the denominator, we're going to get 0 over 1. So we end up again with the indeterminate form. So can I use some trig to rewrite this expression? So let's try. So if I rewrite cotangent in terms of cosine and sine, we might get something to reduce out. So divided by cosine of x all over sine of x. Ooh, this is looking good. I think that my cosines might reduce out. So I get cosine of x over 1 divided by, but when you divide by a fraction, you multiply by the reciprocal. So I end up with the limit as x approaches 1/2.